Hello and welcome to Expert Answers with Jim, in which we answer a question expertly. So in this case, the student has asked about probabilities associated with tossing a fair six-sided die, looking at two events. In event A, as defined, we get a 2 or a 3 show up. In event 3, we're told that a red face shows up. In this case, the even number faces are painted red. So we are to imagine a six-sided die. So numbers 1, 2, 3, 4, 5, and 6 placed on it in one way or another, typically dots. The even numbered faces, that is 2, 4, and 6, are painted red. And so, again, we look at, for event A 2 or a 3 show up. Okay, so that's event A. And for event B, where we see a red face or an even number come up. So this is event B. And so the student has asked about two different probabilities. The first probability that is in question is, what is the probability that event A occurs given that event B has occurred? That's what the vertical line means. And in the second one, they ask, what is the probability of seeing either event A or event B when we roll the dice? That's what the union operator tells us. We see either one or the other. And so we'll address the first one first. That is probability of A given B. Now, this is a probability problem, and very often probability questions are simply glorified counting. And so if we look at event A, there are two ways for us to roll an event A. That is, we have a 2 or a 3. So that's two ways that could happen. We look at event B, there are 3 ways that could happen. That is 2, a 4, or a 6. So there are 3 ways for event B to happen. But the question is, how many ways can event A happen given that we have an event B? And so if we go looking for event A within the subset of event B, we only see one way that this can happen. So there's one way to roll an event A, that is a 2 or a 3, given that event B has been rolled, a 2, a 4, or a 6 has rolled. And so what that means then is a probability that A occurs given that B has occurred is one way out of 3. That is 1/3. There's one way for A to occur given that out of the 3 ways rather that B could occur. So we're going to take the same approach for the second probability. That is, what are the odds that when we roll the die that A or B has occurred? And so what we're going to do is we're just going to list all the different ways that we can roll the die, 1 through 6, and we're going to inspect each one of these, and we're going to make the determination, hey, is this roll in event A or is it in event B or perhaps both? And so if we roll a 1, well, that is not an event A. That is not a 2 or a 3, nor is it event B. That is not even. So this is a scratch. Nothing of interest is occurring here for number 1. If we roll a 2, well, that is squarely an A, right? That is, it's a 2 or a 3, but is also in B. So this rolling a 2 actually matches our criterion, that is A or B, in 2 different ways. 3 is event A, right? If we roll a 3, that is an event A. 4 is even, therefore it's event B. in event B only. 5 is in neither event A, nor is it in event B. And then finally, 6 is in event B because it is even. And so when we finally count here, we see that there are 1, 2, 3, 4 ways for us to observe an event A or B, given 6 different ways of rolling. So therefore, the answer to this simplifies to 2/3. Thank you for listening.